All right, let's get right into it.
Okay, I want to start with this quote. This is loop-based anthropology. What on earth does that even mean, right? Well, that one single sentence, as strange as it sounds, is the key. It's the key to unlocking a story that is, well, it's fascinating and honestly pretty bizarre.
And somehow it connects these weird code names, Vector Kenny and Love Potion number 9, to a dusty old stack of supercomputer manuals from the 1990s. How? We're going to unravel this whole thing, and trust me, the answer is a wild ride through the ghosts of old technology.
To figure this puzzle out, we have to start small. And I mean really small. We need to look at the simplest possible component, a single logic loop, taken from a computer game that's decades old.
Now, in the source documents, they use a specific term for these simple loops, firmware. And I know what you're thinking, but this is not the kind of firmware that runs your microwave. In this context, it's just a self-contained, reusable piece of logic. Think of it like a single Lego brick of behavior. Our first example, and the one that really helps us understand everything else, is a piece of firmware they called bug assembly. And its logic was literally just lifted from a simple dice rolling game from the 70s. You know, where you try to build a bug piece by piece.
The core loop itself is surprisingly simple, just 4 steps. First, it rolls a die, that's your random input. Second, it maps that number to a bug part. Third, and this is the critical step, it checks if you're even allowed to attach that part yet. Finally, it either adds the part to your bug or it fails, and the roll is just discarded.
And this right here is where the logic really shines. The whole system runs on a set of simple, hierarchical rules. You can't add a head if you don't have a neck. You can't add a neck if you don't have a body. This concept of dependency is the absolute foundation for everything that comes next. This isn't just a game, it's a basic engine for building things in a specific order.
Okay, so we've got a simple logic loop from an old game. Big deal, right? But what happens when you start looking for more complex ones? Well, it turns out you find them everywhere.
I mean, there's this massive index of this firmware, and the sources are just all over the place. They extracted logic loops from old spy games, space games, even war games. But it doesn't stop there. They also started pulling logic from industrial systems, like the firmware for an HVAC unit, with its simple loop of monitor, compensate, stabilize, or an industrial controller, with its focus on safety checks and cadence. Each one is like a little preserved, distilled piece of behavior.
But the real treasure trove, the source of the most powerful and complex logic, came from a completely unexpected place. The dense, almost unreadable technical archives of the 1990 supercomputer giant Cray Research.
So why there? Because these machines were built to solve monumentally complex, real-world problems. Look at this quote from a 1994 report. It describes how geoscientists were spending 60% of their time just looking for data. The solutions Cray's engineers built for problems like that, data management, workload scheduling, this was battle-tested logic of the highest order. And that was the gold they were mining.
So the key insight here isn't about running obsolete code. It's about seeing these old manuals as a fossil record of human problem solving. Each chunk of logic is a preserved strategy for dealing with the world, basically frozen in time.
So now we have this whole library of these firmware ghosts. What's the logical next step? Well, you start combining them, stacking them on top of each other just to see what happens. And that is exactly what they did. Individual firmware loops are layered, or stacked, to create far more complex artificial agents. The documents call these assembled entities reference builds. For example, here's a reference build they called Vector. What is it? It's a stack of 3 completely unrelated firmware loops. It has the astronaut firmware at its core for trajectory and correction. Then you've got the HVAC firmware for monitoring its environment. And on top of that, the PLC firmware for procedural control. Just think about that. The logic of a space game, a thermostat, and a factory assembly line all fused into one being. What would that even be like?
So now we have these complex agents, built from the ghosts of old machines. And with that, we are finally ready to understand that opening quote and solve our central mystery.
This is loop-based anthropology. All of a sudden, it starts to make a weird kind of sense, doesn't it?
And that's the core of it all. The goal was never just to build a functioning system. The purpose was to create these agents from historical logic and then study them, to observe their emergent behaviors, their weird tendencies, their unique flaws, almost like an anthropologist studying a newly discovered tribe. It's a way to ask, can we predict the failures of complex systems by understanding the quirks of their most basic parts?
And what's the most interesting thing to observe in any subject? You want to see how they act under pressure. So what happens when these assembled minds get stressed out? Let's go back to our simple bug assembly firmware. The source documents show that even this simple loop develops predictable, almost psychological, failure states under stress. When it's cool, it's methodical, but when it gets warm, it becomes obsessive, wasting rolls trying for a head when it doesn't even have a neck. At hot, it starts ignoring its own state, acquiring duplicate parts it doesn't need. And at critical, it completely breaks down, ignoring all the rules and entering a useless, invalid loop. So you see, these aren't just software bugs. They are predictable, observable, emergent traits that arise from the fundamental logic. This is the anthropology, observing the native culture and psychology that emerges when you bring these old ghosts back to life.
And that brings us all the way back to the beginning. Vector Kenny isn't a person's name. It's the designation for a specific reference build, likely one based on that vector stack we saw earlier. It's one of these strange beings, assembled from the ghosts of code that time forgot.
Which leaves us with one final, pretty profound question to consider. If a mind is built not from neurons, but from the fossil record of forgotten machines and abandoned games, what in the world does it dream of?